Okay, this is part of your packet. This is, I call it page 3. It's SOL 7.1C at the top left corner. This one's talking about ordering and different things of rational numbers. I'll try to make this pretty short and go through this as quick as I can with you. Let me find my pen. There we go. All right, so you can read through this, check it out if you need it. Remember, there's no calculator on this part, but I'm going to just go straight into the questions. Okay, looks like I need to zoom out just a little bit. Nah, I'll just scroll. It says, which of the following could be placed in a blank to make a true statement? We got 2/3 right here and 0.7700. So what I'm going to do is I'm going to change this 2/3 to 0.6 repeating. Okay, and I'm going to leave room right there in case I need a few more numbers. We'll put that less than sign, put a blank, okay, and another less than sign, and write my 0.77, okay? And then I'm going to go over here and change each one of these to a decimal if it's not already a decimal, and check and see which one fits. Okay, so the first choice that they give us is 77.5%. If we do Dr. Pepper with this thing, bounce it back 1, 2, it's 0.775. And if I put a 0 in front of that, and you can see that that doesn't fit because, and here what may be a little bit misleading, if you put a 0 on that, that 0.775 is actually bigger, so it would be sitting over here somewhere on the number line. So we can mark out A. Let's look at B, 0.32. If I put a 0 on the end of this, that's 320, and I put, say, oops, that's repeating. I better not do that. Let's put 6s. 66 and 77, we know that, or 770, we know that that 32 won't fit in it. I'm going to go ahead and put this. It's 3 decimal places. 0.320, 0.666, 0.770. That doesn't fit either. 3/5, we know that's 0.6. Put 2 zeros on the end of it. That's too small. That'd be sitting over here. So let's look at the last one, 0.681. If we put decimal 681 right here, it fits right in between 666 and 770. There's our correct answer. Okay. Roll on to number 2 here, which correctly lists the numbers in descending order. I'm going to go over here, and I'm going to use choice A, starting off with just to list all my numbers so I can line the decimals up. 1.5%. Then I've got 1/5, 1.5, and what is that, 1/15. So I'm going to line all these up. Line my decimals up. And using Dr. Pepper here, this would be 0.015. 1/5, we know that that's 0.2. I can add some zeros in just a second. We got, what, 1.5 here. And 1/15, if you put that on a calculator, you'll see that it's got a 0 in front and that 6 repeats. So let's take these out, 3 places for each one. And now I can look at it. What was it asking for? Descending. So we're looking for greatest to least. So as you can tell, this is my first one. Second would be 1/5. Third is 1/15. And last would be the 1.5%. And as I jump back and look, I can tell that answer choice B is what matches that. Okay. Number 3, put the following numbers in ascending. That's least to greatest. 1/20th, 0.120, 120%, and 1.20%. So I'm just going to change all these to decimals. Okay, when I look, 1/20th is in a calculator 0.05. May need to carry that another decimal place because that one's got 3. So I'll just go ahead and put another 0 here. Okay, then that one I don't have to change it. It's already listed the way it should be. 120%, start from here, 1, 2. So this is equal to 1.2. And I'll go ahead and put 2 zeros on the end of it to match everything else. And then this one right here looks like a very small number. From the decimal to the left twice, 1, 2. So this is 0.012. Okay. All right, let's get through here and list them. Since we're looking for the smallest number, well, if you look at them all, it's that one that we just listed. Okay. There's my first one. Second one would be this 1/20th. Third one right here. The only one that's got a whole number is right there. So I could go through here and list. In the original format, and the last one is that 120%. Good. Okay. Slide down to the next one. This one, you pretty much use common sense if you think about it. First thing that came to my mind was, well, wait a minute. There's 2 negative numbers and there's 2 positive numbers, so we can do that. And so I think the easiest one would be to go right here. So we know we got a whole number. Which one of those has a whole number? Well, if you look at it, we've talked all year about how an improper fraction has to have a whole number, and that looks like the only one that would even be close to that. So there's my first positive number. What's the only other positive number left is the 5.65%. And if you change that to a regular decimal, it's 0.0565, which we know would be really close to 0. So now I got the 2 negatives left. Which one's closer to 0? Well, if you look at them, which one's smaller? Okay, or well, not really saying smaller, but which one looks smaller but is closer to 0 and in senses has a greater value? Negative 0.165. Okay, and the negative 5.6. Another way you could look at this is 5.6. What's half a 6? 3. That would be like right here. And since it's 5.6, it's going to go farther. It's really close to being negative 1. So that's where those go. Number 5, select all rational numbers that are less than 1/3, which is nothing more than a 0.3 repeating. So all we got to do is pop through here and find the ones. That one didn't print very well, so if you're looking at that and you can't figure out, that's a 9 on the bottom of that. I noticed that in some of the packets. All right, so we're going something smaller. So since this is positive, couldn't we go ahead and circle any negative number? Because all negative numbers are less than positive numbers, right? And since this is 0.3 repeating, let's look at this percentage. If I bounce back and I go 1, 2, and I rewrite this as decimal 3, 3, 3, 3. There's no bar that says this repeats, okay? So the next number here would be a 0. Well, if we continue our 1/3 out with the 3 repeating, when I get to the 4th one, the next number here is a 3. So this 1/3 is bigger than this one right here because of that 0. So we can go ahead and circle that one too. This one's pretty easy to tell. Well, it's got a whole number. There's no percentage sign here, so we know that's not smaller. And our 1/6. We talked a while back that anytime your numerators are the same, the smaller the denominator, the bigger the number. So 1/6, I think, double check me, but I think a decimal equivalent would be that right there, which we know that that's smaller, so we'll circle that one. Our 3.75%, we're going to move twice, 1, 2. So we know we got a 0 in front of that. 0.0375, which we know is going to be smaller than 0.3 repeating. 2 ninths, if you remember this, for all ninths, the numerator repeats. That's smaller. And this one right here has a 0. So we know that's smaller, whereas our 1/3 has a 3 right there. And that take care of all of them. Only one of them wasn't smaller. Okay? All right, that takes care of that page. Let's jump over to the next page. 7.1D real quick. Okay? This should go a little bit faster than the last one. That last one took a little bit of time. But I'm trying to hurry, I promise. Square root of 256. We all know 16. If you get stuck, pick a number and multiply it by itself and see if it equals 256. Easy way to go around, okay? Which equation represents this model? If this didn't print out well for you, I'm going to show you. If I count these squares, I have 9 on this side and 9 on this side. If you think about area, if you multiply those two, there's 81 small blocks on the inside of that. So if we take the square root of 81, that tells us what one side of that square is going to be. Let's see if we can find something that's close to that. Looks like B. Okay. Number 3 says, what is the square root of 361? Again, if you need to, we know that that's a perfect square. But if you need to take numbers and multiply them by themselves, that's fine. We know that that's 19. We've done that 800 times this year. Okay? None of those other numbers even come close. Which equation represents this model? If you count these are going to be 20, and I'll put that over here where the X is, by 20, which means that 20 times 20 is 400, which in sense tells you that the square root of 400 would be 20. Okay? So let's go look and see if we see anything like that. Right there it is. Good. Go down to 5. Select all that are true. We do this about every week on a daily dose. 144 and 12. That one looks nice. 864. I think that's backwards. Square root should be over here. 169 and 14. That's the one that gets us a lot. That's actually 13, so that one's wrong. 18 and 324 looks really good. 30 and 15 doesn't even make sense. And 225 and 15 looks really good. Good deal. That was a quick page. I like those. Let's go over to the next page. I think this one's 7.1E, and I'm calling this page 5. Excuse me. All right, here we go. Place 2 points on the line which represent the absolute value of 1/2. This one might have been a little confusing for you, but here's what I did. I took and made whole numbers on my number line here. I put a 1 and a 2. And you may have done this a little different, and if you did, you may still have it correct, okay? But if you think about the absolute value of 1/2, there's only 2 things that we could put in an absolute value bar and have it equal 1/2. And that would be 1/2 and negative 1/2. Okay, so what I would do to put 2 dots where these would be, we know one of them would be right there, and the other one would be right there. Okay, what's the absolute value? Ooh, that bar didn't show up very well on my print. Of negative 2/3 is just 2/3. It's asking you how far is that from 0. And then down here it says select 3 that are true. We can look at these. The first one, I know that causes an issue. This one looks good. That negative right there, and we don't talk about this, is actually Math 8, but that would make, it's almost like having a -1 outside of here. -1 times the absolute value of 3 would be -3. So that one's no good. Don't worry about that if that confuses you. It's the same thing here. This one's no good. Now, I want to show you this one, okay, because this is kind of weird. We don't do this very often. -13 equals, and let's write it like this, -1 times the absolute value of -13. Okay, what's the absolute value of negative 13 is 13. What's negative 1 times 13 is negative 13, so this one is correct. And then these are the ones we see very often. That is correct too. Cool, let's go to 4. It says, what is the distance between negative 3 and 5 on a number line? And we've done several of these, but what I'm going to do is draw a number line real quick. Okay, and I'm going to put my 0 about right here. Negative 1, negative 2, negative 3. 1, 2, 3, 4, 5. So I got negative 3 here, and I got positive 5, and all I got to do is count that. And when I count it, I start here, don't say 1, but that's 1, 2, 3, 4, 5, 6, 7, there's 8. So the distance is 8. Which one of these is equal to 8? Right there. Cool. Right, number 5, absolute value of 5/4. Well, I mean, that's kind of a duh. 5/4 is right there, and it's 5/4 from 0. Okay. Hope there's not any confusion with that. That takes care of the 7-1 all the way through. I'm going to stop right there on this, and I'll go ahead and start. I don't want these to be too long for you. I'll start with 7-2 on the next one.